Hello friends, welcome to Geography MCQ's second session. So in this episode again we will be discussing the 25 questions based on the NCERT and even some applied questions. Myself Tharun Kumar, author at Lost Geography through Maths. The first question, a large star eventually turns into a black hole. What does this mean? That means if a star turns into black hole, what it indicates? Option A, it loses its self-bright light. B, it explodes and disappears. C, it can also swallow the light and therefore cannot be seen as it is not reflected. Next, D, none of the above. Let's see the explanation. So usually this is how the black holes look. We know that stars are the self-illuminating objects in the universe, and stars at their end stage, we know that again two forces will be acting simultaneously in the stars, that is outward pushing force mainly because of the thermonuclear fusion reaction and the inward pushing force mainly because of the star's excess gravity. That means because of the excess gravity, stars try to squeeze themselves and turn into a very small structure, or tries to reduce in their size. So when these two forces are acting simultaneously, both the forces get cancel each other and the star size and shape remains stable. So this stage we call it as the hydrostatic equilibrium, as we discussed in the previous episodes. So once the star explodes and turns into black hole, the word black hole indicates, okay, black means we cannot see, and the hole refers to it engulfs everything, whatever the objects comes under its gravitational influence. So when the stars explode, so because of the excess gravity only, they will turn into black holes. So we know that stars are the self-illuminating objects. Once the light of a star, it falls on the any planet. So because of the reflection only, we are seeing the light on the earth. Even because of the reflection on the moon surface only, we are able to see the moon surface. If any object having the highest amount of gravity, it will not allow even the light to escape from its gravity. That means if at all the light gets reflected from any surface, we can see it. But the black holes are having the excess amount of gravity, even they will not allow the light to get reflect from their surface. So even they will engulf the light also. That's why the black holes cannot be seen. And the hole refers to it will engulf everything, what all the objects comes under their gravitational influence. The extent of the gravitational influence of the black holes is called as the event horizon. The event horizon refers to the gravitational influence of the black hole. So that means the black hole refers to it can swallow the light and therefore cannot be seen as it is not reflected. So this option is the correct one. Okay. Next question. The nuclear fusion reaction which occurs in the stars is due to, again very easy question. So option A, hydrogen and helium gases, the huge size of the stars, the extreme temperature in the stars, and the gravitational force. Here the question is asking the nuclear fusion reaction is occurring, okay, but what is the reason for the nuclear fusion reaction? We know that stars are mainly made up of the hydrogen and helium. Again, within this, hydrogen is the 91% and 8.5% is the helium. So because of the excess temperature only, these two molecules of the hydrogen, they are uniting and turning into helium. The main cause for the nuclear fusion reaction is the temperature. That's why it is also called as the thermonuclear fusion reaction. Even the planets are also having the good amount of hydrogen and helium in their surface or even the core. But mainly because of the temperature only, it is possible for the nuclear fusion reaction. We cannot create the nuclear fusion reaction artificially. Okay, it requires a good amount of temperature, that too in terms of the crores together. Our sun is having the surface at the core, it is having the 1.5 crore degree. Because of this excess temperature only, it is supporting the thermonuclear fusion reaction. Okay, so that means not because of the just hydrogen and helium, even these gases are also found in the other planets also. Again, best example is the Jupiter. Jupiter is a biggest planet in the solar system, though it is having the highest amount of hydrogen and helium, but its internal temperature is not sufficient to support the thermonuclear fusion reaction. That's why we call the Jupiter as the failed star. So for the nuclear fusion reaction, the extreme temperature in the stars is the main cause. That too in crores. It is 1.5 crore degree temperature in the core. Its surface temperature is 6000 degrees Celsius, which is equal to the Earth's core region temperature. Okay. So correct option is C. Next question. Which of the following years is considered as International Year of Light? Okay. Option A 2016, B 2018, C 2015 and D 2020. Okay. See again, we know that solar light, sun is the major source of energy and sunlight is the major source of energy for us. In the year 2015, United Nations observed that aim to raise the awareness of the achievements of light science and its applications and its importance to humankind. That's why International Light Year 2015 is observed as the International Year of Light. It is by the United Nations. Okay. So this was held on the January 19 and 20, 2015. This session was held in the Paris. So option 2015 is the correct one. Next question. What percentage of stars in the universe have their solar system? That means within the universe we have a good number of stars. So how many stars are having the solar system? Option A 15, B 20, C 5 and D 10. So what is solar system? Again, as we discussed, the word solar system refers to a sun or a star along with its neighboring planets is called a solar system. So within this 15% of the stars in the universe have solar system. Okay, that means apart from sun, other stars are also having the planetary system. Again, one more word, the planets which are revolving the stars other than our sun, we call them as the exoplanets. Okay, exoplanets refers to planets revolving the star other than our sun. So 15% of the stars in the universe have the solar system. That means they too have the planets revolving them. Next question. The theory of Big Bang is based on which of the following theories? Okay, again, as we discussed in the previous episodes. Option A, convectional current theory, B, radiation theory, C, both A and B, and D, theory of relativity. Okay, let's see the explanation. Again, we know that the theory of Big Bang, it was proposed in the year 1930. So before that, in the year 1925, Albert Einstein, he proposed this theory of relativity. Okay, so based on this theory of relativity only, Big Bang theory was proposed by Georges Lee Maitre. Georges Lee Maitre. Okay, so in briefly, we shall see what is theory of relativity in 6 sentences. We know that light speed remains constant. So light travels at a speed of 3 lakhs km per second, that is constant. Again, it says time is the 4th dimension. Next, faster you move through the space, slower you move through the time. Next, gravity is the curvature of the space-time. Next, time slows down around the heavier objects. And finally, gravity travels in the form of waves. So, based on this theory of relativity only, Georges Lee Maitre, he proposed the Big Bang theory. So, it is option D, theory of relativity is the main source for the proposing the Big Bang theory. Next question. After the formation of the inner planets of our solar system, the remnants of them are called option A, meteors, B, asteroids, C, comets, and D, all of the above. Let's see the explanation. See again, within the after the sun, we have the Mercury, Venus, Earth, and Mars. So after the Mars, we see the good number of rocket debris. We call them technically as the asteroids. So asteroids are the rocket debris which are left after the formation of these inner planets. Again, we know that Mercury, Venus, Earth, Mars, all these we call them as the terrestrial planets. That means having the solid rock surface. Okay. So what are all the remnants which are left out? We call them as the asteroids. Again, when these asteroids, they collide each other, so one of the rocket debris gets separated and move in the inner planets region. So we call them as the meteors. Okay, meteorites. Again, when these meteorites falling on the Earth's surface, within that, in the atmosphere, in the mesosphere region, they may get burnt. So that time we call them as the meteor shower or the shooting star. Even after burning, if its remnants falls on the Earth's surface, we call it as the meteorite. Okay. So asteroid is the correct option. See, after the formation of the inner planets, our solar system, the remnants of them are called as the asteroids. The broken debris of the asteroids is called as meteors. Okay. So comets are from the asteroids, the meteors are originating from the Kuiper belts. Kuiper belts refers to, see, after the asteroid belts, again we have a Jupiter, Saturn, Uranus and Neptune. So after these outer planets, we have a rocky debris and even frozen particles, icy particles. We call them as the Kuiper belts. So from these Kuiper belts, the comets are originating. Next question: the largest asteroid in our solar system. Just we came to know that what are the asteroids. So within this asteroids, which is the largest one? So option A, Ceres, B, Haumea, C, Makemake and D, Eris. Let's see the explanation. So within the asteroid belt, we have one of the biggest asteroid is Ceres. Okay, so this is the actual picture of the Ceres. So this is the largest asteroid in our solar system. So option A, Ceres is the correct one. Next question: after the formation of the 4 outer planets of our solar system, the remaining debris are called as, again continued portion of the previous one. Option A, wood particles, B, Kuiper objects, C, comets and D, all of the above. Let's see the explanation. So as we discussed, after the formation of the inner planets, the rocky debris remnants is called as the asteroid belt, and after the formation of the 4 outer planets or the giant planets, Jupiter, Saturn, Uranus and Neptune, so these rocky debris are called as the Kuiper belt objects. Kuiper refers to the person who discovered this zone. So these are called as the Kuiper belt objects. Again, when these Kuiper objects are revolving around the sun, again they may get collided each other. So one of the broken particle will enter the outer planets region. So we call them as the comets. Again, these Kuiper belt objects are also called as the dirty snowballs, because as they're remaining far away from the sun, as they're residing far away from the sun, because of the very low temperature, these ice particles got completely frozen. Even the Uranus and Neptune are also called as the frozen planets. The temperature is even minus 400 degrees Celsius in these 2 planets. That's why these Kuiper belt objects are also called as the dirty snowballs. The comets will originate from this Kuiper belt. So the correct option is remaining debris of the 4 outer planets is Kuiper belt objects, and the comets will originate from this Kuiper belt. These are also called as the dirty snowballs. Why they are called as dirty snowballs? Because they are also made up of the dust particles, and as they are far away from the sun, the temperature is very low, so we call them as the dirty snowballs. Next question: what is the Goldilocks zone? The word Goldilocks zone refers to, option A, the zone of planets in constellations. Next, B, sun's gravitational field. C, a habitable zone around a star in the universe. And D, distance between the sun and other planets. Okay, let's see the explanation. Goldilocks zone. Again, we know that within the solar system, after the sun, Mercury, Venus, Earth and Mars, even asteroid belts, Jupiter, Saturn, Uranus and Neptune. Only on the Earth we have a life supporting conditions, that is optimum distance from the sun, we have a water, we have a atmosphere, and we have the life supporting gases like the oxygen and even carbon dioxide. Oxygen is for the breathing of all the organisms, and carbon dioxide is for the photosynthesis and even for the greenhouse effect. See, apart from all these 8 planets, only on the Earth we are seeing the life supporting conditions. That means any life supporting conditions around a star can be called as a Goldilocks zone. That means it should be having the water, and even within the water also it should support the water cycle. That means water should turn into, if it is in the liquid stage, after evaporation it should turn into gaseous stage, and again after the temperature decreasing it has turned into condensation, cloud formation, and again it has to reach the surface in the form of precipitation. Then only both the water cycle and the life cycle are similar. If there is no water cycle, life cycle is very difficult to sustain. Okay, so the word Goldilocks zone refers to part of the hunt for the water on other worlds, means looking for planets orbiting a certain distance from their stars. So planets in this zone are neither too hot nor too cold. Conditions could be just right for the liquid water. So if any planet or any satellite object, if it is supporting the water cycle, certainly we can think for the starting our civilization. That's why we are planning for the, or we are targeting the Mars. So after the Sun, Mercury, Venus, Earth and Mars. So here we are residing. As we move towards the Sun, the temperature increases. That's why Mercury and Venus will have a high temperature. Venus is having a almost 400 degrees Celsius. This is the brightest planet. We cannot think about any starting the civilization in the Venus. But after the Earth, we are having the Mars planet. It is after the Earth. That means bit far away from the Sun. That's why we can see any possibility of starting the civilization in the Mars planet. So in that case, we have started the Mars orbiter mission. After that, again we have landed on the Moon also, because it is also lying in the Goldilocks zone. So if there is any possibility of the water cycle there or the presence of any moisture, we can think about the starting the life there. Okay. So Goldilocks zone refers to a habitable zone around a star in the universe. Clear? Next question. What is heliosphere? Option A zone of planets around the Sun, a zone where asteroids are found. Next, C, the zone where Kuiper objects are found. D, the zone in the solar system where sunlight and gravitational force extend. Okay. Let's see the explanation. See, this is the Sun and this is the heliosphere. The word heliosphere refers to study about Sun is called heliophysics or helioseismology. Helioseismology refers to study about Sun, and the heliosphere refers to the zone where up to which the Sun's gravity and the light can penetrate. Okay, that is called as the heliosphere. So option D, the zone in the solar system where sunlight and gravitational force extend. Clear? Next question. In what form the Sun is expelling its energy? Okay, so option A, radiation, B, solar winds, C, electricity and D, auroras. Okay. Let's see the explanation. We know that all the stars are having the thermonuclear fusion reaction. So in that process, they are releasing the heat and light. So again, they are releasing the energy in the form of radiation, in the form of electricity, again in the form of solar winds. Okay. In these three forms, the Sun is releasing its energy. Okay. So these are also called as the solar flares. Solar winds are also called as the solar flares. So that means Sun is releasing its energy in the form of radiation, even solar winds and even electricity. So what are these auroras? The auroras are the special light effects seen on the polar areas of the Earth. See, this is the Sun, these are the solar winds, and because of the Earth's magnetic field, when the Earth's magnetic field receives the solar winds, it creates a special color light effect on the polar areas. So we call them as the auroras. Okay. So auroras are not because of the sunlight or the sun energy. Okay. So because of the Earth's magnetic field and the solar winds, these auroras are created. So Sun is not releasing energy in the form of auroras. So only A, B, C are correct. That means option 1, 2 and 3. These three are correct, not the fourth one. Next question. In which of the following planet or planets do you find the auroras? Again, option A, 1 Venus, 2 Mercury, 3 Earth and 4 Mars. So what are these auroras? We'll discuss once again. Okay, as we discussed again, so Sun is releasing its energy in the form of either radiation, even electricity and even solar winds. So these are called as the solar winds. When the solar winds meet with the Earth's magnetic field, okay, Earth is having the magnetic field at the polar areas. When these two meet, they create the special light effects in the Earth's polar regions. So we call them as the auroras in general. So in the North Pole, we call them as the aurora borealis. And in the South Pole, we call them as the aurora australis. Clear? So, on which of these planets we are seeing the? See again, only on the Earth, within the inner planets, only on the Earth, we are witnessing the auroras, because for the creation of the magnetic field, we know that Earth's core is having the nickel and iron content. Nickel and iron content. So because of this only, Earth's polar regions is having the magnetic field. We call it as the magnetosphere. But not the Venus, Mercury and Mars are having this magnetic field effect. So even we cannot see the auroras on these planets except from the Earth. So option 3, only on the Earth we can see this magnetic or the auroras. Clear? Next question. What is the temperature of the surface of the Sun and the core respectively? Again, we discussed in the previous classes. See, option A, 5,90,000 degrees Celsius and 1.5 crore degrees Celsius. So it is with respect to surface and the core. That means the first option is for the surface and second one is for the core region. So on the surface it is saying 1 lakh degrees Celsius and 2 crore degrees Celsius, 6,000 degrees Celsius and 1.4 crore degrees Celsius, and D 3,000 degrees Celsius and 2.4 crore degrees Celsius. Again, let's see the explanation. See, this is the different layers of the Sun. We know that its color is yellow in color. It means it is having the surface temperature 6,000 degrees Celsius. In order to support the thermonuclear fusion reaction, it is having the temperature 1.5 crore degree Celsius. Okay? That means option A, C, 6,000 degrees Celsius on the surface and 1.5 crore degrees Celsius at the core respectively. Option C is correct. Next question. Neptune is blue because of its excess. Okay, so what is the main cause for the Neptune its blue color? Option A, hydrogen, B, frozen helium, C, methane, and D, ammonia. Okay, so Neptune is a blue planet. Okay, so after within the Jupiter, Saturn, Uranus, Neptune, it is bluish in color. Again, don't confuse with the word. Earth is also called as a blue planet. Earth is called as blue planet because of the 71% of the water in it. Okay, so if you observe from the space region, because of the scattering effect, the Earth appears blue in color, but the Neptune is appearing bluish in color. What is the main reason? Okay, so if you observe the chemical composition of the Neptune planet, even it is having the hydrogen, even helium, methane and ammonia, but mainly because of the methane content only, it is appearing bluish in color. Next question. What is the center of the Milky Way galaxy is called? So option A, Haumea, B, Taurus, C, Gilbert, and D, Sagittarius. So let's see the description. So this is our Milky Way galaxy, and again we know that center part of the Milky Way galaxy is a kind of black hole. Black hole. So because of its excess gravity only, all the stars are revolving around this Milky Way galaxy, and this black hole is technically called as the Sagittarius. Okay, Sagittarius. So option D is the correct one. Okay. Next question. Our solar system revolves around the entire Milky Way galaxy. In which arm it is moving? So option A, Orion spur, B, Prasinakian, C, Bilward, and D, none of the above. Again, you see the previous slide only. So our solar system, it is lying in the Orion spur. Again, we know that almost 1/3 distance from the center, our solar system is revolving around the Milky Way galaxy. So it is moving in the Orion spur arm. Orion spur is the arm in which our solar system is lying. Okay. So option A is the correct one. Okay. Next question. Our solar system revolves around the entire Milky Way galaxy. So at what speed is it moving? Okay. So option A, 7,20,000 kilometers per hour. Again, 5,50,000 kilometers per hour. C, 8 lakhs kilometers per hour, and finally D, 6,30,000 kilometers per hour. Let's see. See, from the surface or the, if you observe like this, Sun, our 8 planets are revolving like this, but Sun is also not constant. Okay, so again, as we discussed, in the universe, all the celestial bodies are revolving one or the other. So sun is compared to the surrounding planets, sun is having the highest amount of gravity. So that's why these planets are revolving around the sun. Even the sun is also part of the Milky Way galaxy. So because of the gravitational influence of the Milky Way, so the sun is also completely revolving around the Milky Way galaxy. So it is revolving at a speed of 8 lakhs kilometers per hour. So per hour it is moving. So from the beginning of the solar system, our sun has completely revolved the Milky Way galaxy 20 times. Okay. So at a speed of 8 lakhs kilometers per hour, sun is revolving around the Milky Way galaxy. So from the beginning of the solar system, as of now, 20 times our sun has revolved the Milky Way galaxy. Next question, what is the study of the sun is called as? So option A, helioseismology, B, solargraphy, C, stellology, and D, heliology. Almost all the words appear same. Let's see what is the correct one. So here we have two words, heliophysics and helioseismology. The science of studying the sun and its influence throughout the solar system is called as heliophysics. Okay, but the word again, helioseismology, this word is coined by the scientist called Douglas Gough. He says that the study of the structure and dynamics of the sun through its oscillations is called as helioseismology. So with respect to purely sun, the word helioseismology is the correct one, and with respect to the solar system, sun and its influence on the solar system, we call it as heliophysics. But here the question is demanding only the study about sun. So that's why the word helioseismology is the correct one. Next question, which of the following layers of the sun will be visible only during an eclipse? Okay, so the question is highlighting the eclipse situation. So option A, corona, next B, radiation zone, C, photosphere, and D, chromosphere. Let's see. See, from the sun again we have 6 different layers. Core region, from the top it is corona region, next is the photosphere, next is the chromosphere, and is the radiative zone, and is the convective zone. These are the different layers of the sun. So this is the corona is the upper layer. Okay, upper layer of the sun. It is only visible during the solar eclipse. That means when the moon completely blocks the sun, the corona region will be visible. In normal times, this corona region is not visible. Only the photosphere we can see, which is a surface temperature of 6000 degree temperature. Okay, so option corona is the correct one. Okay, next question, what causes solar spots and solar explosions to occur on the sun surface? Okay, so the question says we are seeing the solar spots and the solar explosions. So what is the reason? So option A, the difference in nuclear fusion reaction, the difference in the magnetic energy and temperature of the sun. Option C, both A and B, and D, none. Let's see what are these solar spots. Okay, see, on the surface we can witness this kind of black spots, which are mainly because of the difference in the temperature and even in the nuclear fusion reaction. Okay, so because of these two, mainly we can witness the solar spots. That means option, the difference in the nuclear fusion reaction and difference in the magnetic energy and temperature of the sun. See, that means both A and B is the correct one. Next question, what is an astronomical unit? Okay, the astronomical unit refers to what? Option A, the time it takes for the solar system to orbit the entire galaxy. B, measurement of the size of the solar system. C, the distance between the earth and sun. And D, measurement of the size of planets. First of all, the distance between the sun and earth is 150 million kilometers. This is the average distance between the sun and earth. So this is called as the 1 astronomical unit. Again, the distance between the earth and moon is average 4 lakh kilometers. 4 lakh kilometers average. Again, it varies because all the objects in the universe are having the elliptical orbit. Sometimes they will be bit very closer to their parent object and bit far away from the parent object. So in that case, earth is the for earth, sun is the parent object. So the distance between the sun and earth is, it will be varying. So That's why we take the average 150 million kilometers. So that is technically called as 1 astronomical unit. Again, we have a year word 1 cosmic year. 1 cosmic year refers to the duration taken by the sun to go completely 1 revolution around the Milky Way galaxy. So that is around 250 million years. Okay. So 1 cosmic year refers to 250 million years duration taken by the solar system or the sun to go 1 complete revolution around the Milky Way galaxy. 1 astronomical unit refers to distance between the sun and earth, that is 150 million kilometers. Okay, that means what is an astronomical unit? Again, option C, the distance between the earth and sun is called as 1 astronomical unit. Next question, which of the following sentences is are correct? Okay, first, sun rotation speed is more than revolution. Sunlight will take 8.3 minutes to reach the earth. The sun is a very massive star. Let's see the explanation. Again, sun is also having both rotation and revolution. Sun will take 27 earth days for one rotation on its own axis, and it will take 250 million years for one complete revolution around the Milky Way galaxy. That means 27 days is the very speed. That means it will fastly complete the one rotation, and it will take 250 million years for one revolution. That's why option first one A, sun rotation speed is more than the revolution. Okay, so for rotation it will take 27 earth days, for revolution it is taking 250 million years. That's why this statement is correct. Rotation speed is very fast, revolution speed is very slow. That's why it is taking 250 million years. Next, sunlight will take 8.3 minutes to reach the earth. Again, it is also correct. Then sun is a very massive star. No, sun is a very medium or a minor star. We know that UY Scuti is the very massive star. So in front of the UY Scuti, it is a very minor one. UY Scuti is almost close together larger than the sun. That's why sun is a very minor star. So this statement becomes wrong. So here the question is asking which statement is correct. So first one is correct, second one is correct, third one is wrong. So that means only 1 and 2 are correct. Next question, what is the Chandrasekhar limit related to? Okay, option, the minimum size that a celestial body must have to be called as a planet. B, the limit for the sunlight and its gravitational influence. C, the minimum size that a star must possess to turn into a black hole. And finally D, the minimum speed at which an object must travel. Okay, let's see the explanation. Again, as we discussed in the life cycle of a star, we know that stars within the stars, two forces will be acting simultaneously. One is outward pushing force, mainly because of the nuclear fusion reaction, and inward pushing force, mainly because of their excess gravity. Okay, so these two forces will be acting simultaneously, but at one point of time, again we know that stars average life expectancy is 10 billion years. That means after 10 billion years, the nuclear fusion reaction keeps on decreasing, because the hydrogen fuel completely turns into helium. That's why the outward pushing force becomes weak and the inward pushing force becomes dominant, and the stars keep on decreasing in their size. So at one point of time, the density becomes very heavy and the stars get exploded. That explosion we call it as the supernova. That means at the end of this supernova explosion, either the stars can turn into a neutron star or a black hole. So what is the minimum? Can all the stars turn into black hole? No. Again, as we discussed, the only stars which are having the mass more than 1.4 times the mass of the sun can turn into black hole. If they are less than 1.4 times the mass of the sun, they can turn into either black dwarf or the white dwarf. So this minimum limit for any star to turn into a black hole is given by our Indian astrophysicist Chandrasekhar. So the word Chandrasekhar limit to the minimum size that a star must possess to turn into a black hole. Okay. So he is the Indian astrophysicist. Indian astrophysicist. He is also a nephew of the Sir C.V. Raman. Okay. Even Chandrasekhar, he also earned the Nobel Prize for his work on the star's life cycle. Next question. Consider the following sentences relating to auroras. So they can be found on all internal planets just as Earth. They are formed by the fusion of the Earth's magnetic field and the sun solar winds. 3. These can be seen through a telescope on certain special days all over the Earth. At the North Pole, they are called as Aurora Australis, and at the South Pole, they are called as the Aurora Borealis. Okay, so let's see the explanation. So this is how the auroras look. First of all, we know that sun will be emitting energy in the form of radiation, even electricity and solar winds. So when the solar winds reach the Earth's magnetic field, again Earth is having the magnetic field because of the nickel and iron content in its core. Okay, so when this Earth's magnetic field reaches the solar winds, so it creates the special color effect in the polar areas. So out of the 8 planets, Mercury, Venus, Earth, Mars and Jupiter, Saturn, Uranus, Neptune, within these inner planets, only on the Earth we can see this auroras or the borealis effect, but not in the Mercury, Venus and Mars. But again, within the outer planets, Jupiter and Saturn are having the borealis effect. Okay, so again this can be seen with the naked eyes only, not necessarily with the telescopes. Again, this can be seen only in the polar areas, but not in the tropical or in the mid latitude or even in the equatorial region. Only in the polar areas this can be seen. Okay, so come back to the question. So they can be found on all internal planets. No, only on the Earth. Within the interplanets, only on the Earth, but again on the Jupiter, Saturn also we can see. Next, so this statement becomes wrong. They are formed by the fusion of the Earth's magnetic field and the sun solar winds. So again, this statement is correct. Next, this can be seen through telescope, not necessarily through the telescope, even with the naked eye. On the special days all over the Earth, no, this can be seen only in the polar areas. Okay, but not necessarily in the equatorial region. So third statement is also wrong. Next statement, at the North Pole, they are called as the Aurora Australis, and at the South Pole, they are called as the Aurora Borealis. Though again, only the places have interchange. In the North Pole, they are called as the Aurora Borealis. In the South Pole, they are called as the Aurora Australis, because so here it is called as the Aurora Borealis. In the South Pole, it is called as the Aurora Australis. So as it is near to the Australia, it is called as Aurora Australis. So that means first statement is wrong, only second statement is correct, third one is also wrong, again fourth one is also wrong, because North Pole Aurora Borealis, South Pole Aurora Australis, it is interchangeable. So here the question is asking incorrect statement. So except 2, 1, 3 and 4 are incorrect, that means wrong. So option A is correct. Okay. So next question, arrange the following celestial bodies in order based on the time of their formation, that means chronology. So first one, we have a star, 2 nebula and planets, and finally satellites. Let's see which one is the first one. Again, we know that nebula is the source for the formation of the solar system, and for this nebula, Big Bang theory was the basic one. So from the nebula, again stars were formed around 6 billion years ago, we know that. So after the 6 billion years ago star formation, around 4 billion years ago planets were formed. Again, within that our Earth was also one. So on the Earth, again 3.5 billion years ago oceans were formed. Again within the oceans, around 3 billion years ago life started. So again after the planets, they have their planets, satellites also. So that is the chronology. So that means first nebula was the first one, that means 2. Next, after the nebula, we have a stars, then we have a planets, and finally the satellites. So option D is the correct one. Okay. So this ends the second episode. So we have discussed the 50 MCQs in detail. Hope you guys enjoyed this session. For more updates, please watch Sutra Academy. Okay, thank you.